All right, so let's begin. So we're going to take a look at more changes to measurement, as in what happens if we change one of the dimensions of a shape. How do things like area, volume, perimeter, surface area, whatever it might be, how are those affected? So let's begin with something like a circle. So a circle, let's draw it out. We have one with a radius of 6 millimeters. And we want to know what the overall perimeter and area, how those change if the radius is tripled. So we're going to start off with the original. Let's see what the area is and the perimeter is in this original case. And then we'll see what the new case is. So the area is, for a circle, remember it's pi times r squared. And so it's going to be pi times 6 squared. Let's do that in brackets there. And remember to do your exponent first. So 6 squared will be 36, so pi times 36, which will be, if you calculate it out, you will get something like 113.1. So we'll just round it off to one decimal place. Millimeters squared. Okay, what about the perimeter? So the perimeter, which is the circumference of a circle, so the length around it, that's going to be 2 times pi times the radius, which in this case is going to be 2 times pi times 6. And if we calculate that out, we will get 37.7. And I've just rounded that off. So millimeters for our unit. Okay, so that's the original. Now let's take a look at what the tripled circle would look like. So instead of 6, we'll have 18 millimeters. So the area, using the same formula, will be pi times 18 squared. And that will equal 1017.87. So we're just going to round it off to 9 millimeters squared. And then for the perimeter, well, that's going to equal 2 times pi times 18. And if you calculate that out, you will get something like 113.1. So actually the same as number as we have in the top left there. But that'll just be in millimeters as opposed to millimeters squared. All right, so how do these numbers compare? Well, let's take a look. So between the original perimeter and the new perimeter, we tripled the radius, and not surprisingly, the two perimeters, that's actually tripling the original perimeter to the new perimeter. And that makes sense just basing off the picture. If you're extending it outwards, you could see that it extends by 3 the actual perimeter. What about the area? So the area is a little less obvious to see. You have 113. How is that changing when you get to this bigger 1017.9? Well, this is actually going to be 9 times the area. And where's that 9 coming from? Well, the 9 is actually 3 squared. And since area is a two-dimensional measurement, and the radius is going in both directions, it's going not only left and right, but it's going up and down. It, in a sense, when you change the radius, it has a two-dimensional effect on the area. So not only is it multiplying it by 3, but it's doing that twice. So 3 squared, that's how we're getting that. So it's multiplying the overall area by 9. Okay, let's take a look at another question. So the figure below, the box has a length and width tripled. So we'll consider these two bottom measurements, the length and the width, and the height doubled. So we're not doing the same thing to all the measurements. let's take a look at the volume of the new box to the original. So the volume of the original is going to be just 8 times 4 times 2. If you calculate that out, that will actually give you 64 in the centimeters cubed. All right, that was a nice quick and short measurement or calculation. Next, the new box. So the new box, let's draw a very rough diagram here to the side. So something like, wow, that is very rough. 4 times 2, or sorry, they're being tripled, the length and the width. So those bottom ones, 4 and 2, we're going to multiply them by 3. So 4 times 3 is equal to 12 centimeters. And 2 times 3 is going to equal to 6 centimeters. So those are the new length and the width. And the height, well, the height is doubled. So going up and down, 8 times 2, that's going to be equal to 16 centimeters. So let's go ahead and find, I'll write it as the new volume. So the new volume, that'll be 16 times 12 times 6. So yeah, for any sort of rectangular prism, you can just multiply all the dimensions together to get the volume. All right, and what does that calculation give us? Well, when you do that, it gives it a new volume of 1,152 centimeters cubed. All right. So how does this compare to this? It's a little maybe tricky to see, but what's true about this actually is that it's in fact, if you do the calculation, 64, if you multiply that by 18, that gives you the new volume. All right, and why 18? What's special about this number? Well, what did we do? When we take a look at our dimensions, the dimensions changed by, well, if we look at the length, width, and the height, it was 3 times for the length, 3 times for the width, 2 times for the height. If you multiply all these together, that actually gives you the change in the volume in total. So we have to look at each of the individual dimensions that we're dealing with, see how those change to see the change in the volume in something like a rectangular prism. And that's actually very similar to the rectangle we had looked at previously, which had changed in the previous lesson, which had changed by, in a sense, quadrupling because you doubled both of the lengths and the width. All right, let's remind ourselves of conversions. So if you're converting things, what we want to do is we're either going to convert something like a bigger length distance, whether it's like a kilometer to a centimeter, meter to centimeter, whatever it might be. If we're going to do that, we need to take the value. So let's say we have 2.7 kilometers. And then we're going to multiply that because it's bigger. When we convert it to something smaller, like meters, we're going to multiply it by the conversion factor. So the conversion factor is the fact that there's 1,000 meters in 1 kilometer. So you could say times 1,000 meters per kilometer. And that will give you something like 2,700 meters. Since there's a lot more meters in the same distance as there are kilometers. What if you're going from something smaller? So let's say we have a measurement of 58 millimeters. But we actually want to know maybe what is that in centimeters. So then we need to take a look at what's the conversion factor. Well, we know there's 10 millimeters for every centimeter, but this time we're going to have to divide. So whenever you're going from beginning with the smaller measurement, converting it into something bigger, divide that number. In this case, it's 10 millimeters per centimeter. And when you do that, you will get something like 5.8 centimeters. And so there's just a very quick reminder of conversions. So let's apply that to a final problem. So in this situation, we have a given figure, a cube, and it's got a volume of 8 meters cubed. So what is the volume in centimeters cubed? So instead of converting straight from 8 meters cubed to centimeters cubed, we have to be careful because in our conversions, we go back to the table, it's always just a single unit, whether it's like centimeters, millimeters, whatever it might be, to the other unit of maybe just meters or maybe just kilometers. But the difference here is we have meters cubed, centimeters cubed. That will change the conversion factor. So instead, what we're going to do is we're going to find the original lengths or the original sides, and then work our way from there. Because then the original sides will be in terms of just meters, and then we can find out what that is in centimeters. Okay, so if we go ahead and find the original sides, we know the volume is 8 meters cubed. We know that this is a cube, so how would you normally find the volume of a cube? Well, normally the cube is just whatever your side is, times whatever your side is, times whatever your side is, or you could write that as side cubed. So if you have a number, 8, equal to some number cubed, how do we figure out what that number is? There's 2 ways you can think of it. You can just try to think to yourself what number multiplied by itself 3 times, like we have there, gives you 8. Or the calculation strategy would be to do what we call the cubed root. As in, it looks like a square root, but we just have a 3 there. Because the square root normally asks what number multiplied by itself gives you the particular thing, in this case 8. Here we're just asking what number multiplied by itself 3 times gives you that number. And when you think about that, calculate that out, you're going to get something like 2. 2 times 2 times 2. Since, 2 times 2 times 2 equals 8. So the sides are 2 meters. All right, that is step 1. Next, convert 2 meters into centimeters. So what is 2 meters into centimeters? Well, okay, there, we're just getting an extra page. We know that 2 meters, since we're going from something that's starting off bigger into something that's smaller, meters definitely bigger than a centimeter, we need to multiply. And the conversion factor says that there's 100 centimeters for every meter. So we can just do 2 times 100, and that'll give us 200 centimeters. Okay, so that would mean all of the sides are 200 centimeters long, and that leads to the volume, the new volume in a sense, where instead of 2 times 2 times 2, you're going to do 200 times 200 times 200. If you calculate that out, what you'll get is you'll get something like 8 million centimeters cubed. So that's why we have to be careful about making sure we do the conversions the correct way by finding out the individual side lengths and not just converting the original number, because that'll lead to a vastly different answer. But there we have it, 8 million centimeters cubed in an 8 meter cubed cube.